Hello. Welcome to the Optio Drive Assistant tutorial series by Infranor. Today, we will cover how to set up cogging compensation as well as how to use the oscilloscope inside of the Optio Drive Assistant software. This tutorial assumes you have watched the previous videos in the series. Now, let's discuss what we are using in our setup. In our case, we are using the PACHP AK445 PPAC28 firmware option that supports cogging compensation. We are using it with a GDPS 432 as the external power supply, but we are only running the drive at 230 volts AC. For our motor option, we are using the T055-4B with resolver feedback. It is a slotted motor that uses a skewed stator design to improve its dynamic performance. Let's start by opening Optio Drive Assistant. Then click New Project with Auto Detection. Now let's click Detect to discover our connected drive. Now, let's click the wizard icon to start the wizard. If you are looking for more information on the setup wizard, it is covered in a previous video. Only drives that have the customization code 00028 support cogging compensation, and this will be listed under supported functions. We are going to set our operating voltage to 230 VAC and set our braking resistor to internal, then proceed. Here we can see the motor that is registered in the drive. Now we are going to verify its parameters. We limited the motor's max current to protect it from overcurrent. Now we are going to auto-phase the motor. Then proceed to the next step. According to the PPAC procedure, we are going to tune this motor in velocity mode, with minimum following error, set the auto-tuning mode to standard, and the filter type to max stiffness. It is also important to make sure no load is attached to the motor shaft during this initial tuning process. Let's proceed to the next step. Since we configured this page in a previous video, we are going to leave this page as is. We are going to do the same with this page. And the same for this one as well, and then finish our wizard walkthrough. Now we are going to go to the cogging compensation page inside of the project tree. We are going to enable cogging compensation. Then we are going to verify that the motor shaft is unloaded and start the cogging compensation procedure. This may take up to a minute. During this time, make sure that the motor shaft is not disturbed or touched. This procedure will generate a cogging compensation file that can be saved to the drive and backed up to the PC. It is recommended to run this procedure every time the motor is changed, or if the position sensor is adjusted. We are now going to store the cogging file to flash memory. Then click Apply if it's available. In this case, I previously ran this procedure, so it is already applied. Now we are going to store our parameters so that they are saved to the drive's memory. This concludes the setup of the cogging compensation customization. Now I will show you how to use the oscilloscope inside of Optio Drive Assistant. First, we are going to click on Channels and add the IQ torque producing current signal to our channel. Then we are going to add the VELACT signal that represents the motor's velocity. Here you can see the ranges and how the signals are scaled. Over here we have the time base and trigger tab. This is where we change the time per division as well as what our trigger source is and if we would like to include delays or how the trigger is triggered. We currently have this set to positive level. Next is our Measure tab. Here we can place markers on the oscilloscope for measuring. Then we have the Display tab, which changes the appearance of our data. Here we have the Settings tab, which allows us to load scope configurations. Next we have the Files tab, which allows us to save and export our data from the scope. The Print tab and Info tab tell us more about the channels on the node we are reading from. Now, let's create some motion and see what it looks like on the oscilloscope. Let's open the device control page. Then set the units to RPM. And verify that we are in velocity profile mode. We are going to input 50 RPM. Then enable the drive. I am doing this with an input-output switch connected to the drive. Now we are going to tell it to move at 50 RPM. We can observe what's happening in the oscilloscope. We can begin recording by pressing Start. Then once color returns to the icons, click Refresh to update the display. The green line shows us very little ripple in the velocity, while the pink line shows us the current in the motor. Next, we are going to repeat this process with cogging compensation off. Now let's turn off cogging compensation and save the parameters. Then store the parameters to memory. Once the parameters are stored, they will remain through power cycling the drive. Now let's click Start to record and then refresh to update. Now you can see a very clear ripple in the green line, which indicates our motor's velocity. This ripple is from the reluctance that's created from the motor teeth, essentially creating a magnetic resistance to the motor's rotation. This influences the smoothness of the motor, which can be detrimental in some applications. This cogging compensation feature can be used with all modes such as profile position, profile torque, and profile velocity, to name a few, and can be used with most feedback devices. These oscilloscope captures show the performance of the T055 at 50 RPM with cogging compensation on and off. With cogging compensation off, there was a variance in speed of 10%, and with cogging compensation on, there was a variance in speed of 2%. One thing to note is that if inertia is added to the system, and if the RPM is higher than 500, the velocity ripple from cogging torque can be much lower than 2%. In our case, we are running at 50 RPM and with no added inertia, which simulates a worst-case situation. This concludes the tutorial on cogging compensation and usage of the oscilloscope inside of Optio Drive Assistant. Thanks for watching. Feel free to check out our YouTube page for additional tutorials. Also, you can visit our website infranorusa.com for additional product information and manuals.